All right, so here we're going to look at Young modulus, right? So what is Young modulus? Young modulus is the ratio of tensile stress to tensile strain, right? Young modulus is the ratio of tensile stress to tensile strain. So mathematically, Young modulus is equal to tensile stress, right, divided by what? The tensile strain. So it is the ratio of tensile stress to tensile strain. So if I ask you, what is Young modulus? Young modulus can be defined as the ratio of the tensile stress to tensile strain, or Young modulus can be defined as tensile stress over tensile strain, right? So this is very simple and straightforward, right? So you should know that this, if I represent Young modulus as E, Young modulus is equal to stress, which is the tensile stress, divided by what? The tensile what? Strain, right? By the tensile strain. Young modulus is tensile stress divided by what? The tensile strain. So what is tensile stress? Stress is the ratio of force to the cross-sectional area of that elastic material, right? So stress is force over what? Over area, divided by what is strain? Strain is extension over what? The length of an elastic material. Remember, stress, strain, and Young modulus, they are the three physical quantities that are used to determine the strength of an elastic material, right? So in mathematics, if I turn this division sign to multiplication, I will have to what? Invert this fraction. So that will be F over area is times. So when I change this division to times, I'm going to invert this fraction. So that will be L all over what? E, right? So F times L is equal to what? FL over A times E will give me what? AE. This is my formula for what? Young modulus. So I can say that Young modulus is equal to what? Force times length over what? Area times what? Extension. This formula is very important, right? So this is the formula for Young modulus. Again, Young modulus is the ratio of the tensile stress to the tensile strain of an elastic material. And like I said, these three physical quantities, tensile stress, tensile strain, and Young modulus, are used to determine how strong an elastic material is. So it's just a quick recap. Tensile stress is the ratio of force to its cross-sectional area, right? So tensile stress is force all over area of an elastic material. Tensile strain, this is strain, right? Strain. Tensile strain is the ratio of extension to the length of an elastic material. So tensile strain is equal to what? Extension over what? Length. So let's look at this question. A piece of rubber 0.2 meters, 0.2 meters long. A piece of rubber 0.2 meters long stretches by 0.01 meter. When a load is hung on it, calculate the strain. So again, the question is, a piece of rubber 0.2 meters, 0.2 meters long stretches by 0.01 meter when a load is hung on it. Calculate the strain. So what do you understand by strain? Strain is equal to what? Extension over what? Over the length of an elastic material. So a piece of rubber 0.2 meters. So that tells us that the length of this elastic material is equal to what? 0.2, right? Stretches by 0.01 meters. So the extension is equal to what? 0.01 what? Meters. When a load is hung on it, calculate the strain. So strain is equal to E extension over what? Length. So this will be equal to 0.01 divided by what? By the length, which is 0.2. So I'll bring out my calculator and punch that. 0.01 divided by 0.2 is equal to 1 over 20, and that is equal to what? 0.05, right? So that is equal to what? 0.05. This is my answer. So the correct answer here is what? Is Option A. All right. So it's very important that you should know this formula, that strain is equal to extension over length. Then know stress as well. That stress is equal to what? Stress is equal to force over area. Then know your Young modulus. Your Young modulus is equal to what? Tensing stress, stress over what? Over strain, right? So this is very important, and these three physical quantities helps to determine how strong an elastic material is.